It's okay. Hope you're seeing my screen.
Yeah.
Yes, yes. When I talk about project scheming, I literally talk about positioning of columns on your ground floor to other floors.
Yeah.
For example, I downloaded this thing yesterday. And now it works.
The pen.
Yeah. No, how it works, man.
Be checking. Let me get somewhere to write here. A second. I had my book here. Oh, took it. Back.
Okay. So I'm saying,
your screen is it just having those PDFs, or are you sharing something? Your screen is the one which is having just PDFs, eh?
Which one?
I'm seeing PDFs on your screen.
Hey.
Yeah, I thought you were sharing something which I'm not seeing. Sorry.
No. These are just PDFs. Some drawings I made.
Okay.
Yeah. Project scheming. Now, when we talk about project scheming, it's just literally what? Positioning of columns to allow safe transfer of load from the upper floors to the downer floors. Okay.
Okay.
Yes. But of course, you can't be positioning columns anyhowly, because now you have seen this is what you have seen. This is this is where a wall passes. I need to put a column here. Maybe this is a corner. I need to put a column here. No, there are some factors you need to consider. Okay, there are several factors you need to consider while planning to allocate your columns for safe transfer of loads. Okay.
Yeah.
Number one, you should consider the movement of the grid lines. Okay.
The what?
You have to consider the movement, the intersections of the grid lines.
Oh.
It means you have to. The first thing you should consider actually, where two grid lines meet, there has to be what? A column. You understand? Of all, like you're not going to. At first, when you're placing columns, you will not consider being economical. You first put columns of considering these following factors. Number one, where grid line meets, where the horizontal and vertical grid line meets, there has to be a column. Okay. Number two, where two line meets, there has to be a column. Okay. Thirdly, You should also consider the position of load-bearing members. When I talk about load-bearing members, I mean those walls or like those members which can safely transfer load from the upper floors to the downer floors. For example, you talk about a shear wall. A shear wall is a wall constructed using a concrete. You understand? There are those reinforced walls. The reinforced walls are normally constructed, number one, along a longer lift shaft, a lift shaft along like that wall, which encloses the lift shaft, has to be constructed using what? A shear wall.
Shear wall,
Also, also those long staircases, elevators. Is it escalator? Yeah, there's an elevator, there's an escalator. So those moving mechanical machines, where they are to be placed, they have to be what? A shear wall around. You understand? The importance of shear wall, number one, it is a load-bearing member. Number two, it resists the horizontal forces on a structure. For example, the wind, the effect of the wind can be resisted. Systemic, number two, and others. So you should consider the position of load-bearing elements. Number three, when placing column, also you have to consider the spacing. Okay. Now that one of the spacing will come later. Okay. Yeah, that one will come later when you are now trying to be economical. At first, I'm saying you first leave out this thing of being economical. First, consider where two grid meets, there should be a column. Where two line meets, there should be a column. And yeah, those are the two key things you should consider. And then, after that, the next thing you should consider is the one, the spacing. Yeah, the spacing comes now. The spacing of columns should be the minimum spacing of columns should be 3.5 meters. Okay?
The minimum spacing?
The minimum spacing should be 3.5. Okay, between 3 to 3.5. That should be the minimum column spacing. Like from one column to the next should be minimum. Like when I say maybe you have, for example, you have a column here. Maybe you're saying, now I have a grid here. Let me also put another column here. Then also another column here. So if you are to see, for example, this spacing here, you may find it is 1 meter. This is also 1 meter. You understand? So at least the minimum spacing of a column will be 3.5. So I can come and erase this one at least. You understand? Such that
You're writing. You're writing.
I'm writing on the screen.
No, I'm not seeing anything. I'm still on the other screen. I'm seeing the other screen of what? The other screen of PDFs.
Hey.
Let
me say the entire. Sorry, I thought you were here. Sorry.
I'm seeing still the other first page. The other first page.
Oh, stop. You're seeing it?
Hey, I've just seen now.
Okay. So, I was saying this is, for example, this is our column. Let me first Let me first delete everything. This is a line, for example. Let me use this line. Like, let me say this is a first line. Let's say this are what? This is our grid line. I have another grid line here. Okay. Then I have another grid line here. Another grid line here. Another one here. Another one here. Okay. So you come and say the first where a grid line meet, the other one there has to be a column. You come and put a column here. You also come and put. You are considering the first principle, okay? So let me put columns. Let me be putting columns. First, I'm considering the first principle. Leaving out what? Leaving out the principle of the spacing. That is the first principle. I have to consider that. Okay? The first principle. The second principle comes when they say where a wall passed. Where a wall passed, there has to be what? I mean, where two walls meet, there has to be where two walls meet, there has to be a what? A column. Yeah, and I start to draw. Let me check which colors do I use. Let me use okay. Where two walls meet, this one is big. Let me use this. Okay. I said where two, for example, I have this wall. So the wall. This is the wall. Let me say this is another wall. This is another wall. Let me say this is a wall. Then this is a wall. Okay. Now the second principle says where two walls meet, there has to be a column. Okay?
Yeah.
Then I come. It'd be like, okay, where two walls meet, there has to be a column. I check. Where two walls meet, there has to be a column. Where two walls meet, there has to be a column. This is only one. I leave this. Where two walls meet, there has to be a column. You have seen what I'm doing. You have seen what I'm doing. I remove this because they say where two walls meet, there has to be a column. Yes, yes. So I have even this one. Okay? Where two walls meet, there has to be a column. That one has gone. Yes, okay. I come and check. We have column here, 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 we have column there. Okay? Now they are saying also you have to consider the minimum spacing. You go now to the third principle. The minimum spacing should be minimum spacing should be 3 to 3.5. Okay. Okay. Now you come. Let me say now this spacing you're seeing here. This spacing you're seeing here is 2 meters. Okay. Then here we have 3 meters. And let me say we have here. Okay, let me say this is 1. Okay, this is 1. Also, this is 1. Then this is a 3. Okay. I used the next principle, which says the column spacing should be minimum 3. It should be between 3 to 3.5. That is the minimum. I consider 3.5. I come and add this 3 plus 1. It is 4. I see this is 1 meter. This is 3. I come and consider this one 1 meter. This is 3. So also put in your mind also. They are saying the span of beam in Eurocode, the longest span of beam should be 6 meters. Okay, the longest span of beam without a column, like the long, not the column, that one which is running from 1 to 2. Okay? Like for example, a column a beam running from this point to this point, the maximum should be 6 meters.
So 6 for 6 is it for it's for residential, eh?
Residential, let me say that for residential. Also for commercial, for commercial it applies, but
they say what 5 for
5,
commercial. For commercial they say 5, not 6.
not 6. No, yeah, it says 6. It says 6. It says 6, but you can go beyond 6 on the condition when the depth of the beam is directly proportional to the length. Okay? What do I mean when I say you can go beyond 6? Let me say up to 10 meters. But you have to put in your mind that the depth of the beam should be directly proportional to the length of the beam. By that I mean when you are increasing the length of the beam, you have to make sure you increase the depth of the beam. You understand that? So it means now, let me say, for example, if my beam from here to here is 5 meters, this 5 meters is very long. And I was having a beam of 200 by, I was having a beam of 200 by 400, okay? So, of course, let me say, where you want, like, you have seen a way of putting a column, but you see, a column cannot be put, for example, let me say this is a sitting room, like a lounge. It's not advisable to put a column at the center, like in lounge, like, understand?
Yeah.
It's not advisable to put. And remember, your lounge is spanning like 6 meters. Okay? Your lounge is spanning 6 meters, like from here to here is 6 meters. But you're looking at the size of the column, the size of the beam you have chosen. It cannot what? Successfully transfer the load from the slab. Okay? So what do you have? The only thing you can do is what? To come and increase the depth of the beam. Now from 400, you go and change. You can maintain the breadth, but you can increase the depth from 400 to 450. Okay? That's why I'm saying should be directly proportional to length. As you keep on increasing the length, you should also keep on increasing the depth. So now that here I have, let me say, the length of the beam from here to here is 8 meters. Okay, I've been using 200 by 400. So now for it to safely transfer the load, I can now use from 200 to 400, I can change to 200 to 500 or 550 or 600. Okay? Yeah, it means the longer the span, the thicker the depth. Okay?
Yeah.
You should consider that you cannot put a column at the center of a lounge, of a sitting room. The only thing you can do is to increase the depth of a beam. Secondly, you cannot have a beam running at the midpoint of a lounge. Like you cannot have a beam running like this of a sitting room. You know that?
Yeah.
Yes, it should not be running like that. But the only thing, if you want it to run, the only thing you can do is to what? To introduce a slab beam. You know slab beam?
Slab beam.
A slab beam. Now, instead of you using a beam of 200 by 500, you can come and use a beam of which the thickness, no, the depth should be exactly the depth of the slab. So that's called a slab beam. It's going to be a beam which is being embedded in the slab. You understand?
Yeah.
Yes. So by that, you are introducing what? A slab beam to at least carry, like, to reduce the weight to successfully transfer the load from the midpoint of the sitting room to the either side of the what? Of the primary beam. So now the beam you have introduced in the middle here as a slab beam is going to be called a secondary beam. You understand? You know the difference between a primary beam and secondary beam?
Yeah, yeah.
You know primary beam, eh? Because what I know, you see,
The primary beam is the main one.
yes, let me first have some drawing here. So if we have a column here, a column here, a column here, then a column here, okay? A primary beam is a beam which runs from column to column, okay?
Yeah.
From one column to the other. You understand?
Yeah, yeah.
Meanwhile, a secondary beam is a beam which runs from a column to a beam or from a beam to a beam. Okay? Now, if I have a beam running from here to here, from a beam to a beam, it's going to be called what? A secondary beam. Even though I use this column from one end here, it's still going to be called what? A secondary beam. Okay? Yeah. Those beams which insert a point load on the other is called what? A secondary beam.
Secondary beam.
You get it? Eh? Yes, yes. Let's get back to our column thing. So now I've deleted the other thing. Okay, now come back here. So yeah, I was considering this stuff. So I was saying now, after we were, I think we were considering the spacing. Yeah, considering the spacing. If you now consider this one to be 1 meter, and this is maybe 3 meters. This is 1 meter, this is 3 meters. Okay. We are having a column here. You are having a column here. You are having a column here. Having a column here. Here. Column here. Column here. Column here. Okay. So first of all, you come and consider this is 1 meter plus 3 meters. Those are what? Those are 4 meters. Eh? Yes. So 4 meters you start. You said the maximum length of a beam, the maximum spanning of a beam should be 6 meters. Okay, let's take 5 meters, but it should be 6 meters. Let's take 6. The maximum spanning of a beam should be 6 meters. Okay, and the minimum spacing of a column is 3.5. Okay. If you consider this one, like this spacing is 1 meter, this spacing is also 1 meter. So it means, considering this 3.5, this column has not qualified to be here. Okay. Remember, a column carries how a column carries load. This column carries the load from a beam in a trapezoidal format. No, it's the beam which carries in a trapezoidal but of course, the column carries the weight of the slab that it carries plus the beam is in form of the surrounding area, like halfway of it. Like if we have, let me say, you see, we have this. So this column carries halfway that side and also halfway this side, halfway this side. So what this column carries is from here, here, then here. Okay? This column carries from here, here, and here. Then this column also it carries from here, here, and here. So this column here, so you see in the middle, for it, it carries it like this, half of it, half of this one, and half of this. So when they say you identify the critical column, you are going to come and see which one carries from, you start with the one carrying from one side, you look for the one carrying from one side. If you don't have the one carrying from one side, you go and check the one carrying from two sides, one this side, one this side. From one side, it was, I think, this one. This is carrying from one side, this is coming from one side. One side, like this. This is 2. Then this is also 2.
One side or two sides?
2. This is
The
2.
ones on corners. The ones on corners are always 2.
Yeah, there are 2. This one and this one. This one, this one. Then this one carries 2. Then this one carries 3. 2. This
Which
one also,
one?
this one also carries 2. Not so?
Carries 3. The one in the middle.
The one in the middle, you're meaning this one. This
That one in the middle.
one carries 2, halfway. From here, then from here also. Remember, this is just a division.
Okay, you're meaning this from the slab or from the beams?
Okay, let me say from the beam. Okay, from the beam, this one carries 2. This one carries 2. Remember, the slab transfer its load to the beam. No? Yes, yes. This one carries 2. This one carries 2. This one carries 3, and this one carries what? 2. For this one, it carries 4. So this one, when they say you identify a critical column, you have to identify those columns which carries load in 4 directions. Okay? Yes. So it means, I say, you consider that column also when you're positioning your column. You also consider where can the concentrated load be. So I was considering the spacing from here to here to be 4 meters. So it means this is 4 meters. It means this column you're seeing here is not necessary. You just come and remove it. Come on, I've removed everything.
You undo, just undo.
Yeah?
Just undo. You don't have undo.
It's there, it's there, it's there.
Excuse me, has your power also gone?
Eh?
Is your power, or has your power gone also by this side or not?
Your power's gone.
But I'm on phone. The good thing I'm on phone. I'm going to switch on this to the solar.
It's okay, it's okay. But we have.
For you have?
Eh?
For you have that side?
Yeah, we have power.
Let me switch on the solar. All right, all right.
Okay. Reason what here? The reason I need that. Okay, so okay. Now, like if you're to see this column here is of no use, so I just come and I remove this column. Okay, come and remove this. I also come and remove this. Okay. Then you also see from here to here, this is full, from here to here is full. Just come and remove this. So you can see you're within the range. That's all. The column spacing from here to here, it is 4 meters, 4 meters, 4 meters. So you can see that is all about project scheming. Like, you have understood?
Yeah.
So just make sure you know how to locate the position of columns very well. Then you just identify everything, the necessary things. Okay?
Okay.
And then also, what you should consider is one, there are scenarios like you can have a ground, you can have, these architects, they are very, very funny. Okay, architects, some of them, okay.
Yeah, you're coming in my line. I'm just.
Eh?
Hey, okay, go on. But what you're going to talk about, I'm sure I've already done it.
Yes. And also, sometimes these things, they are not, you see, they are those other guys. Okay, let me say architects. You see, these architects, they can be positive. You see, for them, they're after the facade, like
Yeah. The beauty, eh?
how the building looks like. For you, you're here stressed. You need to identify the what like how you can position your columns. You may find an architect has put for you a building running through like a sitting room, like a wall from the first floor, which can be running to the sitting room, and that wall can be continuous, even what on the second floor. So that wall you're seeing, the partition wall, let me call it like a partition wall because it's running from the midpoint. So it's like a partition wall. Now that partition wall, it's going to insert a point load on the beam. You understand? And remember, we are not supposed to put a column at the midpoint of our launch. Now, this guy is really going to give you hand time. No drop beams will appear in the launch. This guy is giving you time. What can you do? You understand?
Yeah.
So, man, those guys can really give hand time. Yeah. Those guys can give hand time. So,
You see now, there's a school project I was working. In fact, I finished recent. They wanted a hall, main hall on the lower, on the ground floor. Then the second floor to be those staff room and the offices. Yeah. And then the last one, then the last floor, the third floor to be offices. Offices, not office, labs, laboratories, computer laboratory, then science laboratories, library, like that. Eh? Yeah, so for me, I designed, but now, the problem now, remember a main hall, you have to limit the columns in the middle because it is always having what? It needs a clear vision. People when they are seated to be seeing there on the what? On the platform. And that thing was spanning over 15 meters in the width. Yeah. Yeah. Hello. Hello. Yo.
Yeah, man, my internet went off. I don't know why.
The internet.
But it has come back. Yes, you were saying.
I was saying I was talking about the project. That project. I think I will share and we do it as practice.
Yes.
Though I gave it to someone, but he had a beam of 1 meter, 1 meter by 1 meter.
A beam.
A beam.
Hey.
It even went up to 1 by 1 meter. So, but we shall see. We shall see when we start on it.
It is okay. So much. Those are the things the architects do, but
it also actually the problem comes from the clients. So the client tells you actually for them those guys me I knew the problem would come because you have to limit the columns in under on the ground floor, and it was a hole, right? And a hole now the more you reduce the columns and it has more two stories above, that's where you have to increase on your thinking and design. So for them, they already what their main thing, they wanted to use that hall also as a dining. So they couldn't. Me, I had wanted them to put the main hall up, but then they say they want to use the main hall as a dining hall and a main hall. So sometimes when the clients is the one who makes you to do those things. And of course, when you want to also impress him, you also do things. Architecture has no formula. You just do whatever you think about.
Okay. So now let me give you some nice column spacing. Let me say this is a 4. Can have this is 2 4 meters. Maybe this is okay. If you have to have some maximum like 5 meters, you can have here maybe 4, something like that, 4 meters. You can have here. You're seeing my screen, eh?
Yeah.
You can have maybe 4 meters. You can have 4 here. Okay. 4 meters. So now here you can position your. Now if you have something like this, I think it's okay. You can just come and have your column here if they are like that. If they're like that, you can just come. And just come and put your column here. Very well. Considering these spacings, you can have your column here very well. You see? And have your column very well. So these spacings are good. And to give you like a practical knowledge, you like if your building, if your building is like having 1 story, okay? Say I mean 1 floor up. Your column, the column you should use should be. You can use 200 by 200, but that 200 by 200, it's a very small. Do you know that in me I like using T16 in columns? Today there was a building which collapsed around T16.
I heard about it actually. I heard about it, but I haven't seen the news.
Yes. Now that building collapsed. The way I'm saying is because you see these engineers and the clients, they have issues. On them, they want something which is cheap. Remember,
but
you are constructing something which is going to bring for you money. First of all, I can carry my analysis yesterday, but one I was trying to do some design for some church. No sense of change. I was using above of T20 for the church. Man, this guy talked, he complained, he was like, why should I use this thing is over designed? What? And remember a church he was having, the church is about you say it's about no, it's like about 7 meters high. And that church was not being supported anywhere. It was just a wall and the beams in the middle. Remember, this is a church which has sitters up. it has a sitters up. It's like ground floor and first floor. Then it's having a tower. You know those things which goes up in front of the churches, those towers. Yes, it was also having.
Yeah.
So man, this guy was like, why you what? I should have used even 12. I was like, you man, I can never. Now he told me like he complained. So I reduced to 16. I reduced, but I made so each beam is having 6 bars of T16. 6 bars. Remember, a building can collapse and they come for you, you know?
Yeah.
Yes, and the guy wanted us to use 12, T12. Man, T12, T12 is having an area of 226 square millimeter. And if you do an analysis, your area provided, area required, will be more than the area provided. And what is that? What am I doing?
Those are the clients, those people.
For you, if you doing design, make sure your area provided.
What they care about is money.
Yeah, they're looking at that, but man, there are some things you should also do away with them. You can resist something. Can resist something, but the software is okay. They are very, very okay. When you're used to them, you can detail. You can analyze your thing and you see the area. If you see your area provided is more than area required, that is okay. Yeah, this software is a little bit. See, this software, it calculates a lot of things. Now, our manual calculations, it leaves out some things. I was calculating the load to be carried by follow. I calculated and I found it was for the software, it was 363, but the manual did 360. The difference is 63 kilonewtons. That is something small.
Yeah,
that's not something small. So that difference is there. So you should not be reducing it. You should not be over reducing it, otherwise it will cause problems. So please, always in columns, always use T16, even in beams.
T16,
T16. T16 can be used. T16, if you're using T16, you can even go 3 floors up with 4 bars of T16, by the way.
Okay.
4 bars of T16 can take you up to 3 stories.
In a column,
Yes?
Yes.
Okay. Hope you have understood something about preliminary,
Scheduling. Yeah.
Skimming.
Yeah.
Now let's first talk something about let's talk about a project. A preliminary member sizing. This preliminary member sizing one. Let me say preliminary number. Okay. Number one. Let's start with the slab. Okay. With Eurocode says. Let me see. Let me translate for you some drawing. if this is your slab,
Yeah.
if this is your slab, you have decided to be the depth of the slab. Okay, and that is the depth of the slab, which is D. Then from here to here, that is what? I mean, that is the depth of the slab. And a slab can be spanning, like, let me say, a slab can span from here up to here, for example, okay? And it's being supported here, and it's being supported here, okay? Then this distance from here to here is termed to be what? It's termed to be L, which is the span. Okay? Yeah. So the span, the depth, that is the depth D, you have seen it, the depth D is directly proportional. The depth D is directly proportional to
length. The span
is directly proportional to the length of the span. Okay. Is directly D is directly proportional to length.
Yeah.
D. Okay. Yeah. Since D is directly proportional to length, you introduce a constant of proportionality. Your D will be equals to KL. Okay. So if you want to make, let me say, no, it's like this. Your length, it is the length which is directly proportional to the length which is directly proportional to the depth. Okay, it means the depth depends on the length, the span. Okay, as the span increase, you can increase the depth. So if you introduce K here, which is the constant, your D is going to be equal to the L divided by K. Okay? You understand? So for you to find, like, this is preliminary number sizing. For you to find out the estimated size, the depth of a slab, you use this formula. Okay? Yes. And the Eurocode says, let me write it here. It said D equals to L divided by K. And Eurocode says this K, which is constant for slab, it ranges from 24 to 30. Okay? Yes. Now, for example, if you have your beam like this, I mean, you have a slab like this, which has a beam at the extreme end here, which has a beam here, and also which has a beam here, which has a beam here. Okay, let me say this the length from here to here, it is 4 meters. Then this is maybe 3.5 meters. Okay. Now our K is from 24 to 30. So you can choose the value of K between 24 to 30. So any value of K between 24 to 30 is highly recommended by Eurocode. Okay? So for that matter, I normally use 26. So you come and say your D equals to the length. The length is the span, which is 4 meters. That is 4,000. Metric system is given in millimeters. Okay? Divided by 26. So what are you having here?
4,000 by 26.
Take 4,000 divided by 26. That is the 153. Okay. We have 153 millimeters. Okay. So this is a D. Okay. Yes. That is. I'm clearing this thing. I don't know whether you're writing.
I'm writing.
Yes. Can I clear?
153.153.8 millimeters.
Millimeters. This is in millimeters.
All right.
Yes. Now, let me clear this one. Now, you know, if this is the slab, if that is a slab, we know a slab has what? Has bars inside there. You understand? We have those bars there. Have those bars there. And that's there. And we know that the distance from here, the distance from here up to here is given to be H. D, no. From there, it's given by H. You know how?
That is a section of a...
This is a section of a slab, okay? Yeah. So it's given by H.
Oh, I get you.
Depth. Okay? Yeah. We know the depth from there up to the midpoint of this reinforcement is given to be D. Not so? Yes. Which is here that we have gotten.
From that D is from where to where?
D.
That D is.
Let me draw for you here.
The D on the drawing.
Let me draw for you here. Okay. Let me draw for you something here, and you see. You see here. Okay. Now from here, this surface here you're seeing there. Okay. To here. Okay. Is D. Okay. You saying, why using my D?
I'm seeing.
That is D. Okay. from there to here. To here, okay? Now, from here to here, it is given what? It's given H, okay? Yes. Now, for us to find the H, you know, we have something like this, eh? And we have reinforcements here. We have reinforcements here. Okay? I mean, that is a link. We have reinforcement here, we have reinforcement here, and we have reinforcement here. Okay? So this distance D is from the top up to the midpoint of the reinforcement also. This is it. Something like that, okay? So now we don't have this distance from here, the midpoint up to here. Remember, for example, let me say we are using a concrete cover C. We're using a concrete cover C of 25 millimeters, okay? Now, for us to find the entire effective depth from here to here, remember, we have this link. This one is the link, no? Then this is the reinforcement itself. So we have the distance from here up to here, we have it, which is 153.84. You understand? Yes. Now up to the midpoint of this bar. Now let me say that we are using a bar of 12. Let me say 12. Okay. So it means now that you have this value, which is from here to here, which is D, okay, plus. Okay, now you're finding H. You're finding H. You now have this value from here to here, which is D, plus the half. You remember, this one has come up to the halfway of the diameter. Now you have to divide the bar into two to find the remaining up to this outside. Okay. Yeah. So you come and the bar you're using is of diameter 12. Okay. You come and say the bar you divide by 2. Okay. Plus you're using a link. For the link, it is the whole of it, which is L. Okay.
L, right?
L, yeah, which is a link. Then plus the concrete cover, which is C. You understand? You understand? Eh?
Yeah.
And now I said we have gotten calculated our D as 153.8. Okay? 153.8 to be our D, which is from here up to the midpoint of this bar. Okay? Yeah. Now we don't have the remaining from the midpoint of the bar up to here, we don't have, but we can get the remaining for the bar. Then we have the whole of the link. Then we have the cover. Let me say we are using a link size of 8 millimeters. Okay. Yes. So let's start calculating. We have D. Okay. Now this D is 153.8 plus the bar that you're using as a reinforcement, which is what? Which is 12. We need half of it. Half of it is going to be 12 divided by 2. That is what? 6. Yes. Then plus. We are using link of 8 millimeters. Okay. You come and add 8. Okay. Then plus concrete cover. We are using concrete cover of what?
25.
25. What is the total that you're having there? we
How we
are
calculate
having 192.8.
192?
182.8 millimeters. Okay?
Mm.
You understand?
Mm.
182.8 millimeters. So this is the preliminary member sizing. This is the H. Now this is the overall depth of a slab, which is given as H. So it means now when you are going to do your design and modeling, you are going to what? Use the slab depth of 198. But now, you know, this 198 is just a rare figure. Just round off to what? 200.
Mm.
200 millimeters. Now, instead you will use the slab depth of 200.
Mm.
You understand?
Yeah, yeah.
That is number one for slab. Okay?
Mm.
That is number one for slab. Let's go to the next one. Let's go to beams.
Mm.
Let's go to beams. Now for beam, we are still going to use the same formula of,
Mm.
of H equals to HO, I mean D of D
Mm.
equals to the span, which is L divided by K. Okay?
Mm.
Yes. But for beam, Eurocode specifies it to be between the value of K to be between 10 to 15. Okay?
Mm.
Yes. Eurocode specifies for beam to be between 10 to 15. Let's still use the same length. Let's use the same span of 400. Okay?
Mm.
You come. You come and say the span, which is L, the span of L. Understand?
Mm.
The span of L to be 4,000 divided by, now you can use 15, okay?
Mm.
Use 15, you start. You divide, say 4,000 divided by 15. I'm having 266.6, okay? 266.6
Point.
millimeters,
Mm.
okay?
Mm.
Yes, that is D. That is D.
Mm.
But you know, the section of beam is like this, okay?
Mm.
Yes, we have here, we have B. I mean the bridge, which is given by B. eh? Then we have this side. Yes, bro.
You're back.
I've now hotspotted the PC. So at least I wanted us to finish this thing before we.
Yeah.
Yes. I was saying, and this thing also. It's okay. Now I was saying that we have here we have the depth. We have the overall, the effective depth, which is the H. Then here we have the breadth. Okay. So Eurocode suggests the breadth B to be 0.4 H. Okay. So it means for you to find the breadth, which is this one, for you to find that, you need to first find the H. Okay. It means the breadth depends on the depth. So you need to find the H. So as I was saying, I think you have seen that we have gotten a D 266.6. Okay. Yes. Then bro, the thing is disturbing me a lot. The network now, hence I'm on hotspot.
Network is the problem.
Yes. Let's just finish this one of beams and we stop there.
Network or data?
Network. You see, for this, we on the fiber, but you know, when power goes, the what? The fiber network also goes because it's connected directly on the what? On the power. So it goes also. Now I have a hotspot from the data from my phone. The network is not okay. So let's first finish this. Now, as I said, from now we are going to find the H. You know, H will H from first of all from D. Man, am I sharing?
You're not.
I'm not sharing first.
The same way we did for the slab is the way we get H.
Yes, the same way.
Same formula.
Same formula. Same formula. Now you have H. Let's say D plus the bar that you're using, the bar diameter, you divide by 2, then plus the links, the diameter of the link, then plus the complete cover. Okay. Now our D was 266?
Yeah, 266.6.
266.6 plus the diameter of the bar we are going to be using for the beam. Now for beam we use T16. That's going to be 16 divided by 2. Then plus the link we are using still it is 8. Then plus the complete cover for beam. Let's use 30. Okay. So what are we having? Two 6.6 plus.
That last one is what?
30.
8 times what? 8 times 30?
8 plus 30. This is 16 divided by 2. The 16 is the diameter of the bar. Then 8, it is plus. 8 is the link, the diameter of the link that you're using. Then 30 is the concrete cover that you're going to use here.
And I was seeing the 8 again and the 16 out of 2.
No, 16 is the diameter of the bar. The bar, this one here. Yes. Then 8 is link is this one running like this, round like this. This is a link. You know link, eh?
Yeah.
The one you bend in a rectangle form. Remember, it's down here, so you also need to add it plus the cover. So what are you having?
Don't have it right here, maybe to use the phone.
I'm having 300.
Having 3 what?
312
millimeters.
312 millimeters. Now, what you should know with the beam is when you calculate your preliminary member sizing like this, okay? For example, we have 312.6 millimeters, okay? For beam, you take the nearest 50, okay? Take the nearest 50. You understand? Yes, for beam, you take the nearest 50. Then for that matter, Now you can go back for slab. You take the nearest 25.
For the slab,
For slab, you take the nearest 25. For example, now if you have gotten your H to be 145, the nearest 25 is 50, no so? Like that interval of 25, 25. Yeah. Can be 50, 75. You understand? 100. Yes, the nearest. For beam, you take the nearest 50. So here, the nearest 50 is what? 350. Not so? The nearest 50 is going to be 350 millimeters. Okay? Then the breadth B, I said B is gotten from 0.4 H. Now that we have gotten H to be 350. Okay, you calculate 350 multiplied by 0.4. Okay? 0.4. What is the nearest 50 here? The nearest 50 can be 150.
B, you got what?
B. I got
B.
first.
0.4 times 350.
No, you use 0.4. It's not 0.4, it's 0.45. B is 0.45 H. 0.45 H. Okay? Yes, 0.45 H. So when you come to calculating the value for B, you multiply it with the value of H that you have gotten here in millimeters, that is 350 millimeters. When you multiply, you get 157.5 millimeters. Okay? Let's get here. Let me clear this guy. Yes. You have your value of B. You have it as
157.5.
7.5. Okay? Millimeters. But remember, I say that for beams, you take the nearest what? 50. Okay? So here, the nearest 50 is what? 200 millimeters. Okay? So it means your beam is of 200 by 350 millimeters. Okay? Yes. Okay. Oh, if I don't know, okay. You are
Tugende. We move.
We move, eh? Yeah, so it means now your beam is going to be 200 by 350. You understand? Now you know how to size a beam and what?
The slab.
And a slab, yeah. Then you know schematic skimming. Okay. Now For column, let's handle it later. Just like we are going to do it for 10 minutes only, then we are going to model. I mean, we are going to calculate for loadings, how to load a structure. Okay? How do you see?
You're meaning you're saying to we have
Eh?
we have for column, and then tomorrow we have for what?
No, tomorrow, what we are going to do for tomorrow is just calculating the loading, yeah, how to load the structure in Tekla. So tomorrow we are going to open Tekla and load the structure. That is after first calculating. We first calculate we do the preliminary member sizing for column, and then we go and do also the calculations for loading, dead load and live load. Okay. I think you still have the other structure that we modeled.
The one which
Yes?
you did the other first time.
The first one, yeah.
I think I didn't do it, but we can do it in a few minutes.
It's okay. So otherwise, how was everything?
This one was very, very informative.
Okay.
Very, very interesting. I've liked it so much.
Okay. Yeah, that's really how shall be pushing. And of course, if there's anything that you want to know, you can still ask me, whether being right now or later. I'll be there always to assist you.
No, okay. I don't know if it's just how long can it take for a quorum? Is it also like this short?
No. You see, today we have been disturbed by the power
Power.
issue. Yeah. So tomorrow I just make sure I squeeze it within 10 to 15 minutes, maximum 20 minutes, and we go to calculating for the loading. Okay.
Is it a bit long? Because I wanted to by the time I come tomorrow, I know anything during this member sizing, and I have finished both all the elements, slab, beams, and columns. But if
It's okay. It's not long, but
we can just finish with it maybe, so that I just complete member sizing. I be reviewing.
really, I'm going to do something just now. That's why I wanted us to stop here.
It's all right.
It's okay, man. Thank you for attending.
Welcome.
It's okay, thanks. Good night.
Good night.
Tomorrow I will squeeze for you sometime and we are going to do. Okay? Tomorrow is Saturday?
I think, yeah, Saturday.
Yes. Yeah, so tomorrow we are going to do it.
Okay.
But tomorrow I want us to do for maximum 2 hours. But of course, I will summarize everything within that time. Okay?
Yeah. Actually, it's better we finish the backer. Is it the background knowledge, and then we start on projects? You know, the more you do the project, the more you do more projects, the more you meet challenges and you learn more.
Yes.
So we should focus a lot on projects so that we can meet very, very many challenges and we see how to overcome.
It is okay.
All right.
Okay. Thank you so much. Good night.
Good night.